key for this lock, and if we insert it, we can open the lock. Now, what we have here is a Dallas iButton for the simple models, for the normal models, a cloning device. It's now programmed to the last key it read, and if we now hook up this reader, if we hook up the key to the lock, it's not going to open. And to operate this thing, we first need to short the two poles.
Make a shortcut. Make a mechanical shortcut.
No.
And then the lock wakes up.
You hear the code is not correct, but now we will read our black key.
So we're now going to copy the black one.
So we push the button. Now the key is red. The key is red, and if we now hook up. Now the lock will open, and the log file will register that the black key has opened this lock. So whoever is the owner of the black key is now in the log files of the system as he opened this device. So on the simple models, the log files are not always as reliable as you might think at first.
Now, and that in itself is a risk, because people think, it's an electronic lock. I can give out the key to somebody. They can relatively easy duplicate it, read it out. The serial number is even stamped on the key itself. Yes? Yeah, okay. And it's not high security. Now, I know this is not really something new. What we also have is that you can actually scan the locks. What we found is that if you buy a lock and you order the keys from the same manufacturer, that they have in their warehouse, they may have 1,000 or 10,000 keys laying around. And these are programmed in a sequential batch. So there are 10,000 numbers that are followed up after each other, meaning that I have one of their keys. I can more or less predict what key space the users in the field will have, which is a silly attack. If you have this lock, you should get your locks, your keys from Sweden or from some other place, or order them online. But whatever you do, don't order them with all at the same manufacturer, because these keys are grouped. And this is actually an example of
we have a demonstration of the Dallas iButton scanner. As we all know, does every key have a specific number? I'm looking for Does every key have a specific number? And if you know in which range a specific number is, you can put that range into a computer or a laptop, and then with the laptop you can write a program so that he scans automatically all these numbers. So if the range is, for example, between 0 and 1,000, a signal will be created by the laptop, and one by one all these combinations will be dialed till the lock finally goes open. That will be demonstrated now. The lock must be activated.
So first you short it.
You hear peep, peep, peep. And every peep is an incorrect combination or an incorrect key. So he is trying and trying, and if it stops, you have the correct number. So I counted that approximately every combination is 1 second. So within 1 hour you have 3,600 combinations.
Now even though we thought we had relatively good contacts with Salto, we said, we want to build a scanner and cloning device and test it. Can you send us an extra lock? And they send us a model that works with HAR iButtons that are not only a serial number but actually do a challenge response. So and that lock is not in the catalog. We later learned it does exist for government and special companies. But if you are Joe Blow, you will get this lock with a simple iButton key, which still is a relatively good lock, if you ask me. And especially if you take into account the way Salto solves the problems, but just fixing them. And I really like that approach, and I can appreciate that. Yes, compare that with software vendors. Now, unfortunately, not everybody has the same philosophy as we did. And here we see Ullman and Sacher. It's a company that actually I didn't hear of before this whole magnetic ring attack. But all of a sudden, out of the blue, there is a video where somebody demonstrates that if you have this purely electronic lock, which works with challenge response cards, they found a way to bypass it by using this magnetic ring, twisting it around the knob. One way will open the lock, and the other way it will close the lock. Even though I greatly admire this trick, I thought it was really, very low and a dagger in the back of this Ullman and Sacher guys. I mean, why put this online without notifying them and just boom? It even got more dirty as after this video, even more disturbing videos came up. Let me see. This one. It's like somebody really had a score to settle with these people. The Ullman and Sacher people really were trying to fix the problem, and I don't know. I don't know what happened, but somebody, I don't know. So we, of course, were interested in the technical details of this attack. Oh, I hear we have 15 minutes. Ooh, I'm going to hurry. We were interested in the technical details of this attack. We thought in first that turning the magnetic ring that had magnets in it was creating some current in a coil. Just as with a dynamo, if you spin magnetic field around the coil, energy is being generated. And we thought that was actually driving the motor, but this was not the case. It was turning a measurement wheel. In the lock, there is this magnetic sensor / counter. And, okay, Han?
Okay, I will tell in short some how the trick works. This is an X, and this is a metallic part, and a magnet part, and this magnet part rotates if you serve the lock with an ordinary key. What the magnetic ring was, if you rotate the ring around this X, this magnet was grabbed, and the X also started rotating.
Why is the magnet there?
The magnet is here because there is here a counter, and this thing counts how many times the X rotates. So if the X rotates 5 times, the lock says, hey, I'm open. And to get closed, he has to rotate 5 times that time, and if he counts 5, it stops because the lock is closed. So the magnetic ring grabbed this magnetic part, and it rotated, and then the lock went open. So Ullman and Sacher thought we built in a counter. So the counter counted normally till 5, but if you come with a magnetic ring, you rotate it more than 5 times, and if you rotate this thing more than 5 times, the lock gets on tilt. It stops. It blocks. Because the lock thinks I am being manipulated. So that was the improvement of Ullman and Sacher. So if you came with a magnetic ring and rotated more than 10 times, the lock blocked automatically.
Yeah.
Okay, wait. Then there was a new trick which came by the lockpickers. They came with a paralyzer. They put a big paralyzer on the lock, and then the whole circuit, the whole electronics burned. So the counter didn't work anymore. And then you came with your magnetic ring, and still the lock went open. So the improvement of Ullman and Sacher, the second improvement didn't work. So Ullman and Sacher said, okay, then we have to make a new improvement. And the new improvement is good, because they put a light sensor here, and they make the X of plastic, and they put a black dot or a black